Hello and welcome to 12.2 where we're going to be learning about sine and cosine. And these are going to be some more ratios just like the tangent was. So let me go ahead and get you guys started. Tan is short for tangent. We learned that yesterday. Sine, it looks like sin, but it's actually pronounced sine. Sine is going to be short for S-I-N-E. That's how you actually spell sine. And then the cos is short for cosine. And if you look at your calculator, you can see these three buttons, tan, sine, and cos, or cosine. And so those buttons are going to relate to the different ratios that we're dealing with. Now, of course, all of these, tan, sine, and cosine, those are all going to deal with a right triangle. If you don't have a right triangle, you can't use tan, sine, and cosine. But if this is theta right here, I'm going to label this triangle just like we did yesterday. Which side is the hypotenuse, which is the adjacent, and which is the opposite. So I'm going to look here, and I automatically know where the hypotenuse is. It's going to be across from the right angle, so I'm going to label that hypotenuse. I know where that the opposite is going to be directly across from theta, so I'm going to go ahead and label that opposite. And of course the third side that I don't have labeled, I'm going to label that adjacent. Now, yesterday we learned that tan of theta is the opposite side divided by the adjacent side. Sine and cosine are going to have similar ratios. We're going to be using different sides though. Let me show you what the ratio for sine is. Opposite divided by hypotenuse. So that's going to be the ratio for sine. Start memorizing these. The one for cosine of theta, so once again I'm going to use the same angle. This time it's going to be the adjacent divided by the hypotenuse. So sine and cosine are very similar in that they both have the hypotenuse in it. It's just that sine is going to be the opposite and cosine is going to be the adjacent side that you use. Now, I'm going to give you guys kind of a quick way to help memorize how you do all of this. There's something called SOHCAHTOA. If you can remember SOHCAHTOA, that will help you remember sine, cosine, and tangent. And I'm going to show you how to go about using this. So the way that this SOHCAHTOA works is that the S stands for sine. The O stands for opposite. And the H stands for hypotenuse. So what we have here is sine, according to our ratio up here, is opposite divided by hypotenuse. So if I can remember I can remember sine equals opposite over hypotenuse. So if I can remember the orders of those letters, then I've got it. The same thing will go with the C. C stands for cosine. A is adjacent, just like the ratio adjacent over hypotenuse. So A stands for adjacent, and H stands for hypotenuse. So if I can remember ca, I can remember cosine equals adjacent over hypotenuse. And then of course the last one will follow that same order. I know that tangent is opposite over adjacent, just like tangent equals opposite over adjacent. So we've got SOHCAHTOA. Let's try example 1. In this example, we want to find A, B, and C, the missing parts of our triangle. We know that this is a 35 degree, and we know this is the hypotenuse is 400 feet. I'm going to go ahead and label, just so that I'm aware, I'm going to label my hypotenuse. From A, this is my opposite, and my adjacent, just so that I'm aware. Actually, I take that back. I'm going to wait on the A and the O, but I do want to remember that that is the hypotenuse. I want to start by finding angle A. Don't think too hard on this. What we have here is a triangle, and we know that all of the angles of a triangle add up to be 180. So what I'm going to do to find A is I'm going to take 180 minus 90 degrees minus 35, and that's going to give me the missing piece. So it's that simple to find A. But now that I know A, that's going to help me with some of these other things. For instance, to find angle B, or sorry, side B, I can use either A or 35 to help me find B. Now, I'm going to go ahead and use 35. If you decide to use 55 instead, everything's going to work out. But let me go ahead and just use 35. According to 35, B is my opposite side. C is my adjacent side. But I don't have to worry about C yet. I have the opposite and I know the hypotenuse. So I'm going to look for, in my SOHCAHTOA, I'm going to look and see which one of these involves an opposite and a hypotenuse. So I'm looking over here and I see an O and an H combined under the sine. So I'm going to use sine to help me figure out this problem. So I'm going to use sine of my degree, which is 35, equals opposite. I don't know what my opposite is, so I'm going to call that B, divided by my hypotenuse. I do know my hypotenuse to be 400. So I'm going to put 400 in that spot. Then I'm going to plug sine of 35 into my calculator. When I do that, I get 0.57. And then on the other side, I have B divided by 400. I'm going to multiply both sides by 400. At this point, it's simple algebra. And I'm ultimately going to get 229.43 feet. And that is how long B is. Now to do C, we're going to do a very similar process. I'm going to continue working with a 35-degree angle. And according to the 35 angle, C is going to be the adjacent side. So I'm going to look over here and see adjacent and hypotenuse. Which one, and there's multiple ways that I can do this, but I'm going to go ahead and work with my adjacent and my hypotenuse. And when I look over here, adjacent and hypotenuse is going to deal with cosine. So I'm going to use cosine. Once again, you could do so many different ways to figure out what C is, but this is the way I'm choosing. So I'm going to put in cosine of 35 equals adjacent, which is C, divided by hypotenuse, which is 400. So I have cosine of 35 equals C over 400. I'm going to put cosine of 35 into my calculator, and I get 0.82 equals C over 400. Multiply both sides by 400, and C will be 327.66 feet. And that's how you find the missing parts. Last example, and then you guys can work on the problems. Example 2 says we want to find theta. I know that this side of my triangle is 35 feet. I know that this side of my triangle is 44 feet 5 inches. And I know that this is theta. What we have here is, according to theta, this is the hypotenuse. This side is going to be the opposite, so I'm going to label that. And then this side is the adjacent. So I'm going to go ahead and label that with H, O, and A, hypotenuse, opposite, and adjacent. And then before I continue much further, I'm realizing that we've got feet and inches in this problem. So I'm going to convert this inches into feet. So the way I'm going to do that is I'm going to put 44 feet 5 inches. I'm going to convert the 5 inches. So what I'm going to do is I'm going to multiply it by 1 foot is 12 inches. So I'm going to do a little conversion. So I get 0.4. That's how many feet, or 0.4 is what 5 inches is in feet. So ultimately I have 44.4 feet that I'm really dealing with. So on this problem, I'm going to go ahead and scratch out 44 feet 5 inches, and I'm going to put 44.4 feet in its place. Now all of my units are the same in my problem. Next, I have to figure out, okay, from theta, I know my adjacent and I know my hypotenuse. So I'm going to look up here and find which one of these, the SO, the CA, or the TOA, deals with adjacent and a hypotenuse. Looking up here, cosine does. So I'm going to use cosine. And I'm going to do the adjacent, which is 35, divided by the hypotenuse, 44.4. Now, I'm going to divide 35 and 44.4 to get 0.78. In order to get theta by itself, because ultimately I want to find theta, to get theta by itself, what I'm going to do is I'm going to do the cosine inverse. That's cosine to the -1. And that will cause the theta to be by itself. And we did this yesterday with tangent. You plug that into your calculator, so you'll say cosine -1 of 0.788, and you should get an answer of 37.97. Once again, to get the cosine -1, you might have to hit the second button on your calculator in order to get that correct. I'm done. Go ahead and try the problems.